Good morning, everybody. How are you today? Welcome to the first time we're going to be doing a PSAT math practice review packet with yours truly, Mr. Dramas. So sit back, relax. I'm going to go over 5 problems every morning. So hopefully you can look at your packet and say, wow, I know exactly what to do now. Or, yeah, Mr. Dramas, I already did that. We're good, right? So let's work out a few problems. Teachers, please go ahead and pause me so students can have an opportunity to either collaborate or work out the problems again as they see them so we can use Pride Time effectively, okay? So go ahead and pause me at any time during this process. You thought you paused me, you didn't though, okay? So let's go right into number 1. So 2 to the 8th power is equal to one of the 4 choices. So these are exponents, right? Which means there are 8 2's multiplied times each other. There are 4 4's multiplied times each other. So on and so forth. So how do I solve this? Well, if I have a calculator, it's pretty simple. I'm going to put 2 to the 8th power in the calculator, which will give me 256. And what I'm going to do is I need to find which of these 4 choices gives me 256 as well. It just so happens that the first choice will give me 256 when I put that into the calculator. But it's not going to be that easy, we believe, right? You're probably not going to have a calculator for this portion. So what do? Well, 2 things. 1, you really could multiply all these out if you wanted to. And then go, that's 4, and that's 4, and that's 4, and then so on and so forth. And then get to 256 and see which one of these matches. Or we can use some exponent rules and exponent properties to break these things down to a little bit nicer, right? So I know that by an exponent rule of multiplication, I can do 2 to the 4th power times 2 to the 4th power. Now, the rule is when I multiply exponents with the same base, I'm adding the exponents. Now, I know that that's still 2 to the 8th, but what I did here was I broke it down a little bit easier. See, now, I think anybody can multiply or put this in their head, 2 to the 4th power, and go 2 times 2 times 2 times 2, 4, 4, 16. And then you can multiply 16 times 16 to get your 256. What I'm saying to you here and now is, I can very easily do 4 to the 2nd power times 4 to the 2nd power. I know that's 16, and I know that's 16, and you're going to get the same 16s, right? You know this wouldn't work because if I broke this down, this would be 4 to the 2nd power times 4 to the 2nd power times 4 to the 2nd power. Wow, that's serious business. 6 to the 3rd, that's way too big. And then 8 to the 3rd, we're looking at things that we don't want right now, okay? So I know that through a little bit of logic, I can figure out that my choice is A. All right? Nice. Number 2. Simplify the square root of 25. Now, I don't see an operation here. I don't see a plus or minus here, which means that it's multiplication, okay? So the square root of 25 times the square root of 49. If you wanted to, you could put parentheses around these two. So you know for certain that there is multiplication going on. Again, if there was a plus sign in here or a minus sign in here, then I could use something else. But I'm going to multiply those things. Please identify first before you go crazy and start multiplying 25 times 49, right? These are perfect squares. This is 5 times 7. So you would have saved yourself a lot of time. 25 times 49, I don't even know what that is, all right? We got an answer of 35 here. Bam. Very tricky, right? No plus minus sign, can't do it, all right? Multiplication, boys and girls. If it doesn't have a plus or a minus, it's got to be multiplication. Wow, word problems. That was scary. All right. Jason wants to cut a rope that's 60 feet long into several equal pieces. Okay, so let's highlight some information here. 60 feet, equal pieces with nothing left over. Nothing left over. How many pieces will he have if the length of each piece is the greatest integer possible? So integer means number, right? Now, this is one of those problems that the answer choices will significantly help us, okay? So I basically need to take this 60-foot long rope, cut it into equal pieces with nothing left over, so no remainder, okay? I need to have the greatest integer possible of those pieces. So basically, let's run down the list. Well, if I have 2 lengths equal, that means that each length is 30 feet. It's pretty big. The greatest integer possible, greatest number possible, pretty big. If it's 4, it's 15 feet each, times 4. 6 would be 10 feet, and 10 would be 6 feet. So we're looking for the greatest integer possible. If I cut the 60-foot length of rope of length, into 2 pieces, I'm going to have 30 feet. Equal. Greatest integer possible. Tricky problem. I don't even know what it's saying, but because we broke it down into circles and underlines, we've identified what it's really asking us. Next one. Which of the following is true? All odd numbers are prime. Some odd numbers are prime. No odd number is prime. Okay, so let's take a look at some odd numbers, right? You know what's odd and even, hopefully. So odd numbers. 1, 3, 5, 7, 9, 11, 13. Okay, we can stop there. Just get a little sample. So you write this down on your paper. And let's take a look. Well, they're all odd numbers, so that's good. What does prime mean? Well, prime means that it's a number that's divisible by itself and 1. So there are no other factors. There is no other multiples that I could put into that number. Like 10, for example. 1 times 10, 2 times 5, not prime. Okay? 3, prime. 1 times 3. There are no other factors, no other whole number factors that go into that. So let's take a look and see. Well, that's prime and odd. That's prime and odd. That's prime and odd. That's prime and odd. Whoa! 1 times 9 and 3 times 3. Well, just 3, right? That's an odd number, but it is not prime. Let's just keep going. 11, odd and prime. Odd and prime. Well, we have disproved number 1. That can't be right. Which means that this can't work either. Some odd numbers are prime. I would say that that's some. So it doesn't say most, so that'd be tricky if it did, but it just says some. And then number 3 says no odd number is prime. Well, clearly there is an odd number, at least one, that's prime. So our answer is 2, which is B, which is B, which is 2. All right? Not bad. So sometimes you got to do a little bit of investigation. You got to write down some odd numbers and see if they're prime. Boop, boop. If 9 times a number is 36 more than 3 times the number is what? We need to build an equation here, boys and girls, and teachers. So let's go from left to right. Let's write this equation out. If 9 times a number, right, let's write that. 9 times means multiplication. So I'm not going to write that, though, because I know a number, right? You can use n or x or any variable, any letter that you want. I just like to use the first letter of what it's asking me. So if 9 times, right, this is multiplication because I'm putting those together, is equal sign 36 more. Well, 36 more is 36 plus adding, yes? 36 more than 3 times a number. Okay, see how we have number here? Number. We're going to use the same variable because it's looking for the same thing. So 9n equals 36 plus 3n, 3 times. The number is what? Okay, so there is no more equal sign because we stopped here. We're solving this equation. So I'm going to draw my little line down. I don't want to move the 9n because then we get some things that are crazy. Because if I move this 9n away, meaning subtracting it, I'm going to have 0 here. I don't want that. I'm going to move this 3n to both sides. And I'm looking for a balance, yes? That cancels. That's 0. 9n minus 3n is 6n, and that equals 36. Now the opposite, the inverse operation, is to divide by 6 on both sides. N equals 6. D is my answer. Boys and girls, I hope you enjoyed this as much as I did. This was fantastic, okay? Tomorrow we're going to go over numbers 6 through 10. Have a great day. See you later.